Our next session is System Composability using CXL by Kurtis Bowman and Mitch Wright from the CXL Consortium. Kurtis is the Marketing Working Group Co-Chair of the CXL Consortium and Director of Server System Performance at AMD. With more than 25 years experience in architecture and development business justification of server storage, commercial and consumer computing projects. Mitch is a systems architect and designer with over 25 years of experience in enterprise server technology development, currently the CXL system architect at Liquid. Take it away, guys.
Well, thank you very much. Let me see if I can get my share going here. Let's see. All right, is that coming through?
It is perfect.
Perfect. All right. Thank you for the great introduction. Today, Mitch and I are going to be here to talk about system composability using CXL, something that CXL was designed to do. So let me jump right into it. When you think about CXL, we started off at kind of 1.1. And what that was an interconnect that was very much point-to-point, meant to connect a CPU to a downstream device. And then as we moved along to 2.0, we actually started putting it together as you think of as a kind of a PCI environment with a switch, but it still used all of the memory semantics that were there to make it so the CPU can use its standard reads and writes, puts and gets across a very low latency, high bandwidth bus. And this is what's generally in the marketplace today, is the 2.0 type devices that allow, what you see here on the left-hand side is a number of hosts talking to devices that are down below. Those devices could be memory, they could be accelerators, and set it up in a pooling environment. You also see on the right-hand side where what you would get is those hosts sharing those different devices. Generally today, this is done in a memory to where multiple hosts can share individual memory devices, or they can take the entire device themselves. Then as we look forward into 3.0.3.1, those are specifications that the consortium has published and the industry is working to realize in real silicon. So what that does is really bring us into a fabric environment. So now any device can talk to any device. It doesn't matter if I'm a CPU or a GPU, I can talk to any of the memory devices on the bus. And this is stuff that Mitch will get into in his part of the presentation. Going from a kind of a graphic form to more something that's readable, really what you look at is the devices that we have in the marketplace today are in the 1.0, 2.0 offerings. And then as we get into the next year or so, we're going to start to see the 3.0 and the 3.1 come out. And what you're going to find is that it brings in that multi-level switching that I showed in the picture. It also brings in a much larger FLIT, so you can actually move data better. And then it brings in all those fabric capabilities that we were talking about. In addition, we won't talk a lot about them, but it does bring in some security enhancements and some ability to build a better memory expander as we look out into the DDR6 and beyond time frame. And then what we're here to talk about is a little bit about the Fabric Manager features. At a high level, you've got additions of a fabric decode and routing requirements, a host-to-host communication with what we call global integrated memory, or you'll hear it called GIMS. But that allows not just CPUs to talk to downstream devices, but CPUs to talk to CPUs in other systems. And so you can start to share memory that maybe was unused in one system into another system that can take advantage of it. And then we also have direct peer-to-peer on our .mem support. And what that means is now I can talk to a memory device regardless of what I am. So GPUs can talk to memory devices. Obviously, CPUs can talk to those memory devices as well. But it's something that couldn't be done until we got into a fabric environment. And then finally, we came up with a set of APIs for the Fabric Manager, so it's very easy to talk into CXL devices by using that Fabric Manager as a standard interface. With that, I'm going to actually turn it over now to have Mitch talk a little bit more about these features for you, and then we'll pick up questions at the end.
Okay, thanks, Kurtis. Next slide, please. So the first, the 3.0 and 3.1 specification specifies a port-based routed switch, and we moved past the legacy of the PCI Express hierarchy switch structure. And the benefit of a port-based routed switch is that it's an address mapped switch structure and a more fabric-oriented architecture and topology. One of the key features of port-based routed switching and the 3.1 specification is that we move past the 256 device limit of PCI Express, and now we have a 12-bit device ID for 4K nodes. Next slide, please, Kurtis. Okay, so in the starting with 2.0, but now enhanced in 3.0 to support the features of 3.0 and 3.1, we have the Fabric Manager API, FM API, where the management of the fabric and devices are done through the Fabric API and out of band. So now with multi-host systems, no single host is able to configure and change the configuration of the fabric or other host devices and endpoints. This is all handled out of band through the Fabric Manager and the Fabric Manager API. And as Kurtis mentioned, there's now the global integrated memory, where host-to-host communications are now and mapping are now supported, along with device-to-device mapping and peer-to-peer operations. Next slide, please. So again, to emphasize the peer-to-peer operations for memory to memory, and device to device, and that these operations are managed through the Fabric Manager API. And this is a port-based routed topology. Next slide, please, Kurtis. So in a larger system, we'll see a memory fabric with devices and disaggregated memory systems and memory devices, where we'll have embedded CXL type of devices in the enclosure, where we have the enclosure managed through an API and the devices are managed through the CXL Fabric Manager API. Now the larger fabric is managed by the Fabric Manager, and the CXL specification specifies the API, but doesn't fully specify the Fabric Manager for the system. It specifies the API for the devices and the switches and endpoints. In a larger system, such as the one we have here, we'll have hosts that are BMC managed through Redfish, CPUs and other devices through Redfish. So the CXL Fabric Manager enables these higher level protocols, higher level standards, APIs, to call into and manage the CXL devices, supporting a rich composable infrastructure. Next slide, Kurtis. And we actually got through this pretty quickly, so we're going to have time for questions. So the main point is that the management ecosystem, fabric management ecosystem, starting with the DMTF Redfish specification. DMTF has done a mapping of the CXL Fabric Manager API to Redfish. So now we have the foundation of Redfish to support other industry standards. And these are actually links, or not, you can't see this in the presentation, but these are links to the DMTF contributions and mapping. There's a CXL Redfish mapping for 2.0, and then there's an ongoing one for the 3.1 specification. Additionally, SNIA has the Swordfish specification that covers storage that works in conjunction with the Redfish CXL mappings. And then at the highest level, we have Sunfish from the Open Fabric standard that can be the whole system fabric manager that builds on top of these other specifications and APIs. And that's our presentation. Relatively short, but however, we have time now for questions.
Cool, thank you. So if you have a question, you may either raise your hand or unmute yourself or send me questions in chat. I do have a couple that have been popped up during the course of the presentation. Why is CXL relevant?
Curtis,
Like that question? Mitch, do you want to take a first shot at it, or do you want me to go ahead?
Hey, you go ahead. You outrank me.
All right. So CXL is relevant in today's environment really because so many applications are memory limited. They're either limited by memory capacity or they're limited by memory performance and memory bandwidth. And when we see those types of applications, then you start to look at how do I expand my memory without using very expensive high capacity DIMMs. So what CXL allows you to do is add that capacity. When you add capacity, you also are adding memory bandwidth. And so you reduce the load on the local memory on the DDR channels. When that happens, if you have super busy DDR channels, you actually can drop your overall latency in the system, as well as you start to realize that performance advantage of having more memory bandwidth and more capacity. Now, if you're in a situation where you're completely constrained by the cores and the compute, then CXL really isn't there to help out with that other than its interface into an accelerator that might help offload your CPU. I don't know, Mitch, if you wanted to pick it up from there.
Yeah, well, CXL is fundamentally disaggregates memory out of the compute, which it's been there for quite a while. And now we can scale memory along with compute and other resources such as accelerators. So once we disaggregate it out of the system, now we have a scalable bus, a scalable fabric that can add bandwidth and capacity. And we maintain the strong deterministic protocol and semantics of a memory bus. So that's very useful and powerful in a system. And it allows us to build composable systems where we can not only disaggregate, but we can reallocate and scale those resources appropriately for the various workloads.
Cool, thank you. Another question.
Yeah, maybe if we go.
I'm sorry.
Oh, go ahead.
No, please.
Yep. Jump in, Phil.
Oh no, I was going to go on with the next question if you finished.
Okay.
This you may have already answered this question. What can I do with CXL today, and when are the 3.1 features expected to be at the in the market products?
Yeah. So if you look at CXL today, as we look at this slide, 2.0 allows for this host-based routed switching And so what it means is as you go from the host, if you're coming down to a memory device or maybe an accelerator here, in order for this accelerator to go up the chain, and get to something else down here, you actually have to go all the way up to the host and all the way back down, because PCIe and CXL switches prior to 3.1 didn't know how to route within a switch. When you start to look at port-based routing, the real advantage is, I can have a device that's on this far left-hand bottom side talking to a host up here, or even under the device on this switch, and I'm really down to 2 hops. If you compare that over to this side, right, I've got a number of hops to go from one side to the other, right? I've got to go through a couple switches to the host and then down back through the couple of switches. So you really limit the amount of hops, which reduces your overall latency and improves your performance. 2.0 is out today. You'll see those switches available from some of the companies that are part of the consortium. Expect 3.0, 3.1 to be out, call it a year from now, maybe 18 months from now, as that spec gets put into practice.
Okay, and then we had a follow-on question, which I think you may have actually answered. This is how do things like switching and memory pooling impact system performance and design and flexibility in heterogeneous computing environments?
Well, certainly whenever we disaggregate, and first I'd say I think it's pretty clear we'll have there are 2.0 devices in flight, and that we'll see them probably this year, and more of them. But certainly whenever we move and disaggregate memory directly connected from the CPU, there's a latency burden, and however the CPU suppliers and traditionally know how to account for that latency burden by larger on-die memory and on-package memory, maybe. So that's sort of the way to get around the latency burden. We also see that there are workloads that can that clearly benefit from the new latency tier of, let's say, hundreds of nanoseconds to a few microseconds that are much order of magnitude faster latencies, lower latencies than, say, SSD storage.
Yeah,
along with the benefits of scaling, that now we can scale for capacity, or we can build a fabric, a topology that scales for latency, or one that scales for capacity, and so forth.
Yeah, just one small piece to add there is, I think when you look at performance, you've got to consider what performance means to you and where your bottleneck is. Yeah, and that's the advantage of a composable solution, is if you find where your bottleneck is, you can address that directly with this composability that CXL brings to the table, and allow you to only increase the areas that you need to, as compared to previous generations where you said, I just don't have enough, I need to buy a whole new system. Now you can enhance the one you have.
Cool, thank you. Let's see, we have another question. Do GPUs need to have CXL support to access remote memory through a CXL fabric? And is there any GPU vendor claiming to support CXL?
I'll start with the first part, or the second part of that question. Right now, I don't know of any CPU or GPU vendor that's out there with a CXL interface. And for access to memory, PCIe allows access to memory. It's just not going to be the low latency access. So if you had CXL attached into your device, perhaps like we show on the next page here, where you've got some memory out here, if you have an accelerator sitting behind your host, you can still go through the host to get to that memory. Or you can go through the host, if you wanted to set up a gym, you could get to other memory that's available to it. So yes, you can. It's just not going to be optimal performance-wise.
Yeah, it's CXL shows up as system memory. So the GPU traditional or legacy GPUs that are on the PCI Express bus would address the would see the memory just as though it's system memory. And there are not a GPU specifically, but there is an FPGA supplier with a CXL, very high performance CXL interface. So there is the capability of doing acceleration devices today with CXL directly attached. So in a CXL fabric.
Do we have any other final questions? We're running a little bit early. Okay. Let's see here.
Yeah, I mean, if there's not another question, just one thing I was going to highlight on this slide is a new thing for 3.1 is to allow accelerators to talk directly to memory. And so, a little bit about what Mitch was talking about with the FPGA. Once you have your accelerator attached via CXL to CXL Fabric, then you can start to put your data set in memory that it can directly talk to. And as our data sets get larger, having CXL memory available for expansion really increases your performance of the overall system, because instead of having to hop through the host using a PCI interface and over to memory somewhere, you're having that direct access. And so your access goes down into the hundreds of nanoseconds range instead of microseconds range. And if you did any sort of need to swap out to disk, it really increases your performance because you're becoming much faster than you were expected to be in a previous generation.
Cool. We actually got a really good question. Thanks, Sean. Can you discuss how security is envisioned by sharing memory between systems?
Yeah. I don't know. Do you want to take that? You want me to take that one, Mitch?
Well, I'm kind of grinning because security is a large topic. It's a big topic, and there's a full working group with all the primary members that are spending a lot of effort on the security model, the IDE security model for 3.1 and going forward. So I'm not prepared to talk about it. I think it's a full presentation in itself, and so I think we might need to queue that up for another presentation. However, I would like to emphasize again that with regard to open fabrics and Sunfish, that the CXL has put down the foundation so that it can play well in an open standards environment, starting with Redfish and then moving up through the stacks, and is ready to be integrated into these open standard management interfaces, and has been demonstrated actually by at least one company.
And as an architect on the Sunfish project,
bit,
I was going to say, as an architect on the Sunfish project, I totally agree with that statement.
Thank you.
Yeah, and a little bit on the security front. So we're taking advantage of the fact that we do ride on top of some of the PCIe work, and so even with 2.0, you have IDE as a link encryption, and then as we move into 3.0, 3.1, you get into the trusted execution environment, and then we've layered on top of that what we call TSP, or trusted execution environment security protocol. So we do look at a full end-to-end data in-flight, data at rest. You can do the encryption, of your data at one end of the wire or the other, so there's a lot of options there. But as Mitch mentioned, to really do it justice, you'd have to take another 30 minutes to talk about that security. But just know that we constantly are looking at security because it's one of the key areas when you have data as something that you're moving around. You need to make sure that it's properly taken care of.
And Matt is asking, will Open Fabrics be developing a standard IP networking, such as IPO-CXL, like your IP over IB support, and LibFabric RDMA support for host traffic with CXL 3.1?
Matt, I'm not a Open Fabrics. I'm not. I don't know the roadmap, so that's up to the Open Fabrics Consortium.
And the short answer is probably attend the Open Fabrics Sunfish project and ask that question directly to the architects. Okay. Do we have any other questions? See if there's anything, if anyone's raised a hand, or we will. One moment, please. All right, it seems to be all the questions. Any final words?
I just want to say thank you again for the opportunity to come talk with you about CXL and answer the questions that you had. Great questions that were sent in. Really appreciate those. Thank you very much to Mitch for joining me in the presentation as we talk about how CXL can be used in a composable environment. And I'll leave the last words to Mitch himself.
Likewise, and next week we have the first CXL DevCon out in San Jose. And I'd encourage everyone to, there's a lot of interest in it, a lot of activity, and it's a good way to get a pulse on what's really going on in the industry and the excitement around CXL.
Cool. Thank you very much. Appreciate the time.